All right, welcome back, folks. I hope everything's going well with you, and hope the math went okay. And what we want to do now, and this is getting us near the end of this chapter, is we want to look at the lab program. And what we're going to mainly look at today is the lab guide, which has an activity with it that you're going to be working on. But before you can do that, you have to get signed up to use the labs. And the labs I'm talking about are the KT virtual physics labs. These are something that we started building in 2006 and have been kind of adding to them and editing them and updating them and all for over the years. There are now thousands of students using these labs, kind of scattered all over the world, lots of college students all over the place and high school students. So they've worked out pretty well, and that's what you're going to be using in this course. You'll be using them at two different websites. And the one you'll be using mainly is not the one I'm going to talk about today, but in a very quick video later, yeah, right, very quick. Later, you'll see how to work with that other website. But we want to get signed up with at the regular KT Virtual Lab site today and do some activities there. So that's what we need to do. Now, you should have already received an invitation to join the the lab site to sign up for it. You should have either gotten it as an email or as possibly a message. But you must have an email address that works in order to do this. You cannot sign up for it without one. So you should have seen most likely an email, and in the email you had a link to click on that gets you started setting up your account. And let me show you what that's all about. Let's see, creating, yeah, that's not it. I have so many things here, I don't know what they all are. Let's bring that up. Okay, ultimately this is what you want to end up looking at, and let me just show you the real thing here. Or let me just back up a moment. In the mail, you should have found this little box of information. That's basically what you'll have there, and you click on this link right here to get you going. Now these numbers right here are bogus. They won't get you anywhere, but they'll at least get you to this. If you clicked on them, you would see this particular page, and you can't go anywhere with it because it's a bogus account number. But this is, when you click on it yourself with your account, you will end up at this page right here, and you're going to then want to fill in some information here. So that's what we're talking about. That's what's going to happen. So I'm going to make that go away, and we're going to now look at something that shows not only what you started out with, but the next step and the next step, and etc. So you'll know what to expect. So you got the thing at the top of the page there. You have a link to click on, and when you click on it, you'll be sent to what I just showed you, which is a page that looks like this deal right here. And this is where you first create an account. These are built into WordPress, and WordPress has a sign-up system which we use for actually enrolling people in the labs, and this is a part of it. And so the instructions down here I hope are clear enough. You need a username, and that username has no spaces in it. It has no underlines. It has nothing but lowercase letters and or numbers. So you can't. Let's see. Yeah, you can use numbers and lowercase letters, and that's all you can use. No spaces, no special characters or anything. And so here, Mr. Bailey here is perfectly okay. Mr. Space Bailey will not work. The next thing is your real working email address. It has to work. And then the next thing here is you choose a password. The password doesn't have the same restriction as the username does. I'm not sure why, but anyway, you need to pick a password, and you need to remember the password, and you need to repeat it down here, and it needs to be correct. If it isn't correct, it'll ask you again to try again. And then over here you have your name, and you can put your first and last name there. There's nothing about, I guess you can use special characters there if you have special characters in your name. That's kind of a novel thing I haven't seen before. This voucher code will will already be here. Okay, then you click on sign up, and if you've done anything wrong, it'll take you right back to here and tell you what you did wrong. And there'll be something on here saying you used an underscore, for example, in your username. What will also happen, though, is both these password entries here will be gone. You always have to resubmit them when you make mistakes and have to fix it. So, but anyway, once you're successful with that, and you click complete sign up, which it says to do right there, click complete sign up, and if you didn't make any mistakes, this is what you'll see, and you'll see it immediately. If you don't see it immediately, there's something wrong, and because it's going to now say go check your email for an activation link. Okay, now that happens instantly, within seconds. It's a long instant. Within seconds after you click the complete sign up, you will get an email at the address you provided. If it doesn't come, if you wait a half an hour and it's not there, it's not like patience is a virtue, you just wait. If you don't get it in a reasonable amount of time, there's an error, and almost invariably that is from misspelling your email address. We found that about 12 to 14% of people, at least early on, were misspelling the email addresses, and once we started making a big deal out of it, it's dropped way down. So you should get that immediately. And it should have something in that looks like this, although this is a fake one here. And so you're told to activate your account by clicking on the following link. Now, the clicking is supposed to open that up. It's actually an address. It's supposed to open up a browser with this as in the address bar. If your system doesn't work like that, you can copy this and paste it into the browser window. And when you do that, you'll see it'll do. I must have clicked it. All right. So it also is a bogus one. Okay. And you'll see account activated. And then the last thing to do, your account is activated, but there's kind of another step of actually getting into the labs. You then go back to the lab website, virtuallabs.ket.org. And over here, there'll be a place that doesn't look exactly like this. It'll have two spaces, your username and password, and then a click to open or whatever it is, or log in, I guess. And when you do it, then your name will be here, and that'll say log out for when you're finished. And right here is the button you click to actually go to the labs. So that's the process. And what I want you all to do is to do that right now. Okay, now in a moment here, I'm going to start happening again. So anyway, turn the video off and do that, and then turn the video back on, and we'll be ready to move on from there. Okay, I'm back, folks. I would trust that in the time you've been away, you've gotten all signed up. If you had a problem, you need to let us know. Write me an email, and we'll get that straightened out. But hopefully you're all set up and you have an account and you're all ready to go, because you're going to be needing it here. Now, what we want to do is we're going to spend some time here working with the lab guide. And one of the main things we're going to be doing is creating equations from data. You've seen thousands of equations in your life, and you may not have ever thought about the idea about where they come from. But just there are these equations out there somehow magically. We're going to make equations in here, and the way we make equations is the way they're all made. Basically, what you do is you notice there's some kind of relationship, and so you start puzzling over, well, what is that's influencing what? Does the weight of this thing influence how it moves through the water, or how big it is? How does that influence how it moves through the water or something? What are the parameters? What are the different variables here? So you start taking data and you say, hey, I see a trend here in the data. And so you then graph the data and you say, by golly, I recognize that graph. And then you can, from knowing what the graph, see what the graph looks like, you can create an equation. And that's the whole point of what we're going to be working through now. Okay, all right. Now, what I want to do, first of all, real quickly, is show you a funky little video. That's pretty funky looking, isn't it? This is what the videos look like when you stop them. What you're going to see, actually, there are going to be three of me. I know it's going to be hard to stomach if we're going to be three of us all here at the same time. This is from a lesson about current flowing through wires. Okay, and here's the basic idea. For example, you have heard the hum of like a transformer or something before. You'll be somewhere in your house and you'll hear kind of a humming noise, and it's coming from like a fan, or maybe you walk outside and you hear a hum coming from like a can-looking thing. It's a transformer up in a pole near your house. This is something that's all around us in our environment, and it is caused by the phenomena that we're going to look at right here. So you're going to see me and me again, and have a little video, and that video has two parallel wires, and there's lots of this going on by the two me's. There are two parallel wires kind of drooping like so, and you're going to see that when I turn the current to pass anti-parallel versus parallel, opposite things occur. Okay, so let's just look at that bit of excitement. Okay, now that was quick, wasn't it? This is at the University of Kentucky. It's one of their demonstrations, and we're going to zoom in on this in a moment. Pink shirts were really the deal some time ago. Okay, they're spreading apart. Now they're back to normal. Okay, spreading apart, back to normal. Okay, of course they're swinging and whatnot. So you saw them spreading apart, and now they're going to slam together. Isn't that exciting? Okay. All right, so enough of that madness. Okay, now, hope that wasn't too much of a shock for all that to come back. So what? Okay, well, you see a phenomena like that, and if you're interested in such things, you think, oh, I wonder what's going on here. Wonder what matters. You think, well, it seems like they went apart at one time and together in the other time, and if you would do this experiment, you find when the wires are going in the same direction, they're attracted to each other, and they slam together. When they're going in opposite directions, they just wiggle a little bit apart. You think, that's kind of odd that they don't act oppositely when you do something opposite, but yeah, they really do, because when they're in the same direction, they start to come together. They now get closer, so the effect is even greater. So they really come together, and when they're going apart in opposite directions, they move a little bit away, and now the effect drops off with distance, and so they don't go very far before they're at equilibrium with gravity. Okay, so anyway, the direction of the current makes a difference, and something else I could have done there is turn the current up and down, and you'll find that the more current there is, the more this force is. So you take that stuff and you get out your graphic programs or whatever and start doing things like plotting well, you'd have to measure forces for that, as a matter of fact. So if you could measure the amount of force that's holding them apart or pulling them together, you could plot the force versus how much current's flowing. You can also plot the force versus how far they are apart. And there might be other things that you might do, how thick the wires are or something. But as it turns out, it ends up with a nice little equation that has both currents in it, because you can actually have different amounts of current, and the difference between them, and also a pi. And that's all that there is in the equation. So this is the sort of thing that scientists do to figure out how the universe works, and they've been doing it for years and years and years. And we're going to be doing things like that here. And so let me go ahead and show you an example of a system that we might look at. Here we have, this is one of our labs here. Here we have a mass on a spring. I'm going to pull it down a little ways, and it's now going to start wiggling up and down. My computer has been really run slowly in here for some reason. So there it is. Now this graph here is y, which is the difference, the distance away from its center equilibrium position. is what the y is, so it goes above it and below it. Okay. Versus time. Well, that's pretty exciting. Okay. Now, what I want to do this time is, how about if I was to pull it down farther so it goes up and down farther? It has farther to go, so maybe it'll take longer. So what do you think that would do to this graph if I pulled it so it has a greater distance to go? Well, then it might take longer, so the wave would be, it would take longer to go through this wiggly business here. So maybe the graph would stretch out or something if I made it pulled it farther. Okay? All right, well, let's see what happens. And it automatically starts, which is pretty handy. Strangely, the amplitude is what we're talking about. The distance from the equilibrium to either extreme is called the amplitude. The amplitude has no effect whatsoever. But wait a minute, it's going farther. But also it's going, on the average, you might say faster, because I pull the spring back farther. And we find that the more you pull the spring back, the more it accelerates and more quickly it gets done. So we just had a null result, and null results are sometimes great, like when the doctor sends off a sample of, your to the lab to check and see if you have some sort of a problem with your whatever, and you think, please give me a null result sometimes. Okay, but a null result here is great too, so it means I can scratch amplitude off the list. Okay, so null is fine. Okay, and it's a type of result. Now, what else might happen? And I'm going to pause this thing. Now I'm going to stop it. Pause just. Okay. It is so blasted hard to catch once you get it going. Oops. Oh, come on, you stupid thing. Sorry for saying mean things. Okay, now, what else might make a difference? Well, something else that we might have a look at here is to say, all right, let's bring this little equilibrium. That's where it started out here. Okay, actually, matter of fact, let me get rid of that. This is equilibrium. Here is the end of the spring when there's nothing on it here. And what I'm going to do is add different amount of weights to it. So there's the original equilibrium. And I'm now going to hang these things on here and see where it comes back into equilibrium. Hopefully you can see the gravitational force acting downward and the spring's force acting upward, although it changes, well, actually it doesn't change direction. So there is a new equilibrium position around here. Now, suppose that I replace that 100 with a 200 gram, which is like so. Where's the new equilibrium going to be? Well, I got pretty close there. Okay. Now, what you can imagine is going on here, if I go to 300, it's going to go down about another equal amount. Okay. So what we have here is a linear relationship. You add a certain amount of force, you get a certain amount of stretch in it. Add some more force, and you get an equal amount more stretch, and etc. So this looks like we have something happening here. And this is typical about how we go about taking data and reaching conclusions. Now, what I want to do now, if I can just find it. No, that's not what I want. I want this guy here. We're finally going to look at this lab guide, which is what this whole activity is all about. What we're doing here, what we're going to be doing now is exploring things like this in this lab guide. The lab guide is, I've forgotten how many pages long it is. We start with section 2. You've already done all this stuff before there with that math review. And so what your job here is to use what I've just shown you and some more things I'm going to show you, and then work your way through this lab guide and do everything that's there. And this will take you a couple of days. But it's to improve your technique or give you technique with this at all, and learn how the apparatus works and all that kind of stuff. Here is some data I've taken with our apparatus, as you'll recognize it there. And what I have here is weight versus length. And by the way, the order of those two is important. As a matter of fact, at the end of this lab guide, you're going to have a thing that's like a homework, but it's partially questions like what I just said, and it's partially taking some data and stuff from the lab apparatus. I just said we were plotted weight versus length, and that's a really important distinction. The independent and dependent variables. What's that all about? Well, what I did was I deliberately varied one thing, and that was the weight that I had hanging on the end. It's actually the weight, but these units of grams are mass actually. But I varied the amount of weight and to see what happens to its length. The thing that you deliberately vary is the independent variable. The one that responds to it is the dependent variable. Okay, so that's their definitions, and that's in here. Okay. The next thing you need to know is when you put them in a data table, there's only one way you do it. You put the thing that you're going to vary in the first column, that is the independent variable, and the thing that depends on it in the second column. Now, incidentally, sometimes, for example, if you look at pressure versus volume in a gas, you could say, well, I'm going to vary the pressure and see what happens to the volume, and vice versa. And they're, one doesn't seem to be driving the other. They work oppositely. Either one you want to change, the other one will change. Here, I can't vary the length and make the weight change. Okay, but anyway, so this one's a very nice, clear-cut example of that. Okay, now let's see how this works. I have some data right here, and what we're going to do is I'm going to go ahead, because this is a Word document I'm working with, I can copy this data and paste it. It's no big deal to type the stuff in, but to help us move things along, I'm gonna do that. So I've copied that data, and I'm now going to, let's go into our lab site here. There's a tab here for labs. When you click on labs, you will see our fabulous collections of labs appear, and each one of these is an image that you click on to access a lab. You see the simple harmonic motion lab, the ill-named simple harmonic motion, because it is not very simple, but there are 7 labs right there. Then there's some more here, and then some more, and some more. Okay. Now the first thing we want is we want to open the grapher. So I'm gonna click on Open Grapher at a new tab. Okay. And now I get this, now I click on it and it'll open Grapher. I've actually already done that, so I may just go ahead and click that and put it over here. No, I won't. I think I will not do that. Open a new tab. Okay. Now, the Grapher program here's X and Y. And there we have again this stuff about where things go. Notice we have X and Y, and by the way, you can't change the titles of those things. The X is the horizontal axis, the Y is the vertical axis. That's another thing you need to know. It seems like you could put either one of them, either axis you want, but what you want to see is as something is changing that you're deliberately changing, what's happening to the thing that responds to it. So you always put the independent on the horizontal axis, and then the dependence on the vertical, and it rises and falls. Now you need to know all 3 of those things, what the 2 mean, where they go on the data table, and where they go on a graph. Okay, and that'll be on the quiz. And okay, now you can enter these numbers in here, and let me just show you. For example, if I start putting numbers in here, 1, hit enter 2, hit enter 3, hit enter 4, etc. That's one way of doing it. You can also, though, hit 1 and then hit tab, and it jumps to the right side. And then I'm now using tab, I go down like so. Hitting enter goes right down a column. Hitting tab goes back and forth. Isn't that special? Anyway, that's kind of handy when you're entering data to know that you can. Sometimes it's nice just to enter a whole column at a time. Like if you're doing 1, 2, 3, 4, 5. Why not just get them all done? So it's return, 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 it goes down. Okay, now, rather than typing the data in, I'm going to click in this box, and it says Control-V to paste data. So I'm going to hit Control-V, and poof, my data is in there. And that's that is the data I took from, from that apparatus. Okay. Now, a couple of things to do here. You'll notice that there it says graphs 1, 2, and 3. We will always, now we might not do it immediately, but generally speaking, before we, like, for example, print out a graph or something, we don't want it to be at the end of this whole page, and you're going to learn about printing out graphs and things here shortly. Clicking these little X's here will bring up other labs, and you're going to learn more about them then, but the top one is the one that our data is being displayed in, okay? And this is weight in newtons. I think that's what that was plotted in. I can't remember. Versus length in meters, I believe. I may be wrong, but anyway, that's what I'm going to put. And now you can drag this to center it here, okay? Likewise on the axes. I think I completely, got that right somehow. So, and here's length down here. Just double click in it and then you can type. Just don't type shift. Okay. Length. Okay. Does that look okay? Now, I don't know about you, but I think those little dots are kind of small. I'm going to right click in this graph and put large points. We should have that as the default. They're actually probably too large, but anyway. So I recommend doing that, just easier to see. Okay. Now what else can we do here? We've got everything labeled. Yep, that all looks good. Now there's something else we can do. This looks pretty linear. Okay. Now there's all kinds of gadgets on the screen here, and let me just show you one of them. But one thing is, notice how when I move over different graphs, their boundary boxes get highlighted, and then notice this box down here, and notice how it gets highlighted to match. Crazy. Okay. Now here's the deal. Suppose I wanted to click something in that box down there to change something in the graph at the top. I want to not go over the one there in the middle and come down here. Now, as it turns out, in this particular case, it really doesn't actually matter, but in some cases it does. So I'm clicking linear fit. What it does in this particular case, I just want to alert you to the fact that it's when you do something like, say, hey, square the y value, it'll do it for a certain graph. The graph that's illuminated is the one that's acted on by in the box. Now what we have here is what's called the line of best fit, and the mathematics behind that's kind of interesting, but you will never in here get involved in how that line gets created. So we have a relationship that we would say is linear, and I hope that that's something that's familiar to you. Now, what have we seen so far as relationships? We've seen a linear one, and we've also seen something else, and that is a sinusoidal relationship. And in a little while, we're going to look at the set of graphs that we care about in this course, and the sinusoidal one we will never see after today. We don't do the math of that is more complicated than what we do in this course, but certainly this linear graph is something within the bounds of this course. Okay, now linear is good. Now, but what do you think when you have a linear graph? You usually look at something like the slope and the y-intercept. I hope that's something familiar to you here. Well, the slope seems to be a measure of how, let's see, actually that's kind of confusing there, because what I did was I just put the wrong labels on the things. Is that right? I'm glad that I didn't do that, because this should be the weight. I want to go back and look at that to make sure that I didn't just do something really insane. Hello, come here. let's, all right. Okay. Yeah, so I just labeled the thing back. I am so sorry. I've done a terrible thing here. Why not? Okay, that makes me much happier. Okay, I caught it because I realized it didn't make any sense. As you vary the weight, the length changes, and so I need to fix this one too. All right, so we have length versus weight, which is what we expected, and fortunately caught before it was all over. Now, so what happens is, as we vary the weight hanging on it, its length increases. Now, getting the linear fit back in here, that's what I was getting ready to talk about when I discovered the problem. As you increase the weight by this much, the length increases by this, increase the weight by this much, the same, and it's just going up step fashion. So that's what the slope is a measure of. This slope down here, and by the way, notice how I ran over it. Notice how the slope changes. This is what I was talking about before. When I'm looking at the blue box, that slope down there is the slope for the blue box. So 3.3 meters per Newton, okay, you get the units from the ordinate and the abscissa. 3.3 meters per Newton is the slope of this. What about that y-intercept? Does that mean if you have no weight on it, it has a certain length? Yes, it does, and that was the original length. Okay. Now, how about another way of, if we go back and look at our, let's see, I've got that simple harmonic motion guy. Okay. I'm going to remove this thing. This right here is that length that we just measured. Okay. Now, there's another way of looking at this and say, let's don't talk about the length. Let's talk about this change in length, because really the weight doesn't directly determine the length. That is, the length is not directly proportional to the length, because right now it has a length but no weight. Okay. It's the stretch that matters, which is the change in the length. And so we could go back in here and take care of that. How would we do this? We could subtract the original length from each one of these. Take 12.8 away from that, you get 0, and here you get 2.0, and etc. What would happen if I did that? Every one of these values, these vertical values here, would drop by 12.8, and this would go right through 0, 0, and we'd have a nice straight line. It's not only a linear, but it's what's called a direct proportion. And that is a real key thing. Linear is one thing, but direct proportion means if I double one thing, I'll double the other. Okay, if I triple one thing, I'll triple the other. So if you were to subtract 12.8 from each one of those, the whole thing will drop down. The y-intercept will be essentially 0, and you'll get a nice linear and direct proportion. All right, let's see. Let's see what we need to do next here. Okay, yeah, on to something new. Now, so what you're going to be doing, and I have a little bit more here to show you some things about capturing images, but what you're going to be doing is going through the lab guide and doing all these activities, plotting this data and making sure you understand them. And now I'm going to go to bring back up the lab guide. And as I said before, you start in the middle at like 2.1, I believe it is. Okay, you start right there and just start working your way through the whole thing. One thing that you'll find right here near the bottom, almost at the very end. No. Okay, you'll find this table I told you about. We've seen the sinusoidal one, which we'll not see again. We've seen the no relation or null result, which is just y as a constant. Okay. We've seen the linear with a y-intercept. That was the first one. Then when we subtracted B, the y-intercept, which is 12.8 meters or centimeters, whatever. I think they're actually centimeters, sorry. Anyway, we subtract that, and then we get a direct proportion. It's a straight line through the origin. And don't mix those two up, because there's a big difference between the two of them. All right. So there is all that madness. Okay, now let's go back to the lab guide yet again. Please come back, come back. Okay, good. All right, I need to get back up a few pages here to figure 9, I believe it is. No, it's figure 3. Okay, now one of the things that you're going to be doing in this lab guide I'm getting ready to show you here is working with this graph of the figure 3 of the pizza versus diameter. And what I'm going to do now is I'm going to bring that onto the screen and show you what you're going to do with this. You're going to save it and upload it. Okay, so let's go ahead and I'm going to grab this stuff. If you have this, you will get these labs in PDF format, and you can't capture and paste the PDF because it'll grab this stuff over here too, and there's just nothing to do about it. If you capture it from there and put it like into a text file or something, maybe you can save some time, but it's not that big a deal. Anyway, but in your PDF, you will not be able to do what I'm doing here. So I've now copied that, and I'm going to control paste it in there, and I'm going to get rid of the line of best fit, and I'm going to go ahead and put this quadratic line in there because this actually is a quadratic relationship here, and that's one of the other ones, and there are two different versions of them, the one that goes like this and the one that goes like this. More on that as we go along. And again, why do we care about this? This is how equations are made. You discover some new effect and you say, I want to say here's the relationship between them. It could be a biological thing. You know, all sorts of things have equations that describe them, and that's what we're working on here. Okay, what you're supposed to be doing next, and I'm going to bring out the lab guide activity in just a moment to show you where this is done, where you use this. You're supposed to capture this graph and save it. Now you can save that to any device you want. You can save it up into you can save it just directly on your hard drive or into a memory stick that you plug in your computer. Wherever you can save it, you just need to be able to save it. How do you go about doing that? Well, there's a little camera down here, and when you click on the camera, the pointer is going to change into crosshairs. And now, there we go. Nothing's happening so far, but what I want to do is I want to drag diagonally across this thing to capture everything in the realm and the region of this graph. Boy, this is amazing how slow my computer runs in here. Maybe it's because I have 17 things open. Okay, and I'm going to now let go, and it automatically pops up a little requester. Now, if you didn't get what you were trying to get, then you could just cancel and do it again. Okay, now I'm going to type a file name in and take it somewhere where I want it and save it. Now, what's very important is you have to put .png at the end of it. So this would be okay, and actually it seems to me it doesn't add that automatically, even though it's a ping file. And if I click save, it will now save it. Well, I've already saved it here, and the way that my computer is set up right now, it doesn't show the extenders there. I've already saved it, so I'm going to go ahead and cancel it. So I now have that saved. Okay, I have that saved somewhere. And now what we want to do is get going on what we came here for but needed lots of background information, the lab guide activity. And yep. Okay, and let's see, it gives you some instructions about what to do, but I've kind of done that ad nauseum. And I'm going to go ahead and continue previous because I've already done some of this, or one of them. Okay. All right. Now, what's going on here? The lab guide has a bunch of questions in it that are kind of different. Some they're not numerical. And I told you before to be expecting this. The blank variable is intentionally changed so as to see resulting changes in the other variable. Okay, let's just suppose that goes there. You just drop it in there, and that goes there and drop it there. Now, I'm not saying that's correct or not, because I wasn't even thinking when I did it, but that's how you do these. You can also drag them out, and all the pressure is off, okay? So that's how this particular thing works, okay? And so this is part of the thing that you do after you've done work through all that stuff in the lab guide for several days. Okay, now you do 4 of those, and then you come down to this deal right here, and here's what's going on. Part of your grade on this is to upload an image of that pizza thing that I just now saved. Now this is the thing where if you look at the end of the lab guide, it will tell you how to do it for the other website, WebAssign, where most of your labs actually will be done. I'll show you that later, but this one needs to be uploaded to our local site into Moodle, and it works just a little bit differently. And the detailed description of what to do is here. So up here, I'm talking about how to set your graph up to look like you want to. I'm saying plot the graph of the area versus diameter of the pizza from the data table, blah 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 blah. Now I didn't change the labels of the axes and things because just to hurry things on. But you need to make sure you do your axes and don't be like me and do them backwards. Label your axes and all that sort of stuff. Put the title on there, and then click all 3 of those so that you can capture just the smallest one. And then I have down here a place where you to save it and call it figure 3. Yeah, this is described in part 3 of the lab on page 19. For the name of the file, use figure3.ping. Okay, don't forget the ping. Okay, now here's what's going to happen when you. Well, actually, I'm actually in. This is a part of the activity, and they are instructions. And this is really kind of wonky the way this works, because I tell you what you're going to do with these things here, but the real things are further down the page. But I wanted to show them to you up here, and it's very confusing to have the same thing twice, which is why I put these, don't pick me, I'm just an image. Okay. Now, so what's going to happen is you're going to find this thing up here at the bottom. This thing's going to appear down below down here, and you're supposed to use it to upload figure 3. All right, it looks like this, okay? And the thing you want to use, well, there are 2 things you could do. If you can grab a hold, if you can go to a file program where you can, like Windows Explorer or Explorer, where you can drag a file and drop it somewhere. If you know how to do that, you can grab it and drag it and drop it right there, and it'll just grab it and it'll have it. Okay? It's easier to do it this way. This little guy right here is a little tool, and if you click on it, it'll open up a file requester where you can go find the file that you were working with. Okay? So I would recommend using this one. Now, if you use this one, then what will happen is as soon as you click on it, this thing will pop up and you'll click Choose File. And I'm going to do this in a moment. You'll click Choose File. You go find the one you want and click Open or whatever, and then it'll change to look like this, and the file name will be here instead of No File Chosen. Okay, and then you'll click on Upload this file and it'll do it. So let me just drum roll, please. Here, this you don't do anything with this is actually an essay thing that allows you to upload images. We're just not having an essay. So you could drag it from a Windows Explorer or whatever, or on your Mac, whatever, drag it and drop it into here, and that'll grab it and it'll be ready to save. Or what I'm going to show you is this right here. I click on this and it's going to have me choose the file. And I know that I put it on my desktop. And there it is, and it's too bad I don't have this set to show the PNG, because if you don't give me a PNG, I can't read it. Okay, and so I'm going to click Open, And just like I showed it before, it's going to be there. And now I click upload this file. And it may say you already have one of these. And ask me if I want to write over it. I don't know. Can't remember. Okay. Oh, and now you see that it's down here. Okay. The little small image of it's down here. Two things about this. First of all, if you don't like it, you can right-click on it and delete it. Okay, or you can upload it. I mean, I'm sorry. You can delete it, then make another, and then create another one. Now, something else that you need to know, and I wish I could zoom in on this. Get it really close to the computer screen. There's a little pink area over here, and that little pink area actually tells to the millisecond when you capture this file. Why do you think we do that? Okay, you can probably guess. So yours is definitely identifiable as specifically, not somebody else's. Okay, so it does stamp the date on it. And so there you go. So anyway, that is how you upload the file. Then there's some more questions down here, and I'm asking you to interpret things. What is the slope? What does this represent? Okay, and you're going to be doing this area versus thickness thing with a pizza. So that's the way that thing works, and I believe that takes care of all of that. Yeah, everything about that thing, except I have one more thing I need to show you. And that is, the lab guide just always wants to be somewhere other than where I want it to be. Okay, here's the lab guide. One last thing. And by the way, this thing right here this is where it shows you how to upload it to WebAssign. It's actually easier. Okay. What I want to show you is this stuff right down here, and this is in your lab guide at the end of it. And I talk about using sketch tools. And so let me just go ahead and show you what I'm talking about here. Okay. I'm going to go back to this, and I'm going to use the same one that I used in that image there. No, what did I use? Oh yeah, I used oh, it was the buoyancy one. Okay. Was it? Yeah. Okay. It was the buoyancy one. And I'm going to now click on this to load it. And if and when, I think we probably are going to do this lab, when you do this lab, you'll be given there'll be some pictures in it in the lab where this needle is not here, because you're supposed to show me what the needle actually read. Well, here's how that works. Here's an arrow. Click the arrow and drag it over here. I can't believe that's hiding underneath there. That has never done that before. It's a miracle. Wow. Okay. Anyway, I'm going to have to check into that, because that has never happened. I wonder if I put a weight on it. This is all about buoyancy. What you do is you lower things in here like so, and water overflows and this kind of stuff. Oh, well, I'm very puzzled. I've never seen that happen before. Anyway, there are arrow tools. There are label tools where you can put, weight there and etc. where you might want to label this. So there are all these tools that you can work with to label things. You'll use them in many of the labs, and that's how they work, although they generally actually do work. So anyway, I think that's the end of it. Yeah, that's all we have to do here. You won't do any of this business with the labels in this one here, but you will in some labs down the way. Hope that all made sense, and please forgive me for doing such a good job of getting my labels backwards. But anyway, good luck with all this stuff, and again, let me know if you have any difficulties. I'll be glad to help. The last thing in this chapter before the test is the pendulum lab, which you'll see one more video about to show you how that works, and so we'll see you then.